So this is a call for action for massive research. And again, AI plays a major, major role there.
We need to bring government along, we need to bring regulation and legislation along.
There's a few dozen utilities in production, full production, running those systems right now, and with clear value. So the answer is AI makes a difference.
I mean, untapped value creation. So this is where the potential is.
Welcome, everybody. I'm glad to see we have a full house on time. Congratulations. It must be an exciting topic. I know I like the topic. We're talking about powering tomorrow. Are we ready for AI in the energy sector? My name is Ginelle Greene-Dewasmes. I lead the AI and energy work at the World Economic Forum, and I'm joined with an esteemed panel here of different perspectives when it comes to answering that question. Introducing our panelists, and I'll just ask you to raise your hand in no particular order. We have Cyril Garcia from Capgemini. He's a group executive board member and global head of sustainability services and corporate responsibility. Welcome. We also have Pedro Vasconcelos from EDP. He's the executive board member and Iberia CEO. We have Thomas Kiessling from Siemens, Smart Infrastructure, CTO, the Chief Technology Officer. And of course, we have Amir, last but not least, Orad from Kraken Technologies. He is the CEO. Let's dive into this conversation. So we want to explore very practically using examples. What are the foundational infrastructure, operational realities for utilities, the policy environment? Pedro, starting with you. EDP is actively deploying AI across its value chain. Why is AI becoming critical for the energy sector, and where does it perform well in operations today?
Oh, thank you. So good afternoon, everyone. So just stepping back, and it's probably now a consensus that data centers are really driving electricity consumption. We are seeing for the first time in many, many years, actually consumption growth. This is already after efficiency, this is already after behind-the-meter generation, and we're seeing consumption growth in Portugal, Spain, in the US, 3% now is the number. And so that in itself is a massive change already coming from all of these LLMs and data centers behind the trend of electrification. What is happening at the same time is that this consumption is growing much more and much faster than the generation, availability of generation. So that's not obvious at this stage what's going to happen to pricing. And the world is also trying to react. And we have all of these complaints around licensing, permitting, environmental constraints on the generation side. Today it takes us 15 to 20 years to build a nuclear plant. It takes us, 12 years to build the first CCGTs that GE announced recently, or even Siemens. It takes 80 years to build a wind project, 5 to 7 years to build a solar project. And so we will see this mismatch between consumption keeping accelerating, at least for now, and the generation trying to keep up, but most likely won't do it in sufficient pace. And so that's, in my mind, it's where AI enters. With this idea of how can we maximize also the existing assets that we have in much more volatile and complex environments. Today we manage gigawatts of assets in single markets, where in every 15 minutes we need to be operating and dispatching hydros, and then gas plants, and solar, and wind, and now batteries. And so how to do everything in an optimized fashion in 15 minutes. From the grid perspective, how can we actually, within the installed capacity that we have today, release installed capacity? We have been managing these grids with static parameters, and the world is real time. And so can AI actually jump in, although it's not doing that yet? Can AI jump in with real demand, real consumption, real climate, and real climate data, and actually release this existing capacity? And then on the final consumer standpoint, and that's eventually where we are most seeing it in our company, is the easy grabbing fruit on managing customers and managing operations on the grid side and managing operations on the supply side. Eventually, managing 4 million customers with call centers that optimize the process paths and connect directly with the operation teams, that's already happening. But where I think the real value is this added alpha, if you want, of knowledge, how to integrate systems, how to directly integrate the final consumption with climate data, with the dispatch of a hydro plant. That management, and we're today moving into markets with complex ancillary services and 15-minute dynamic markets. It's not humanly possible anymore to have optimized systems. But that should not be a bottleneck at the same time. So can AI actually tap onto this nerve of concentration of bids and asks and information, and actually starting to deploy better information and better decisions. So lastly, not the least, but in Spain we had a blackout on the 28th of April, and Portugal and Spain are unique markets in an integrated way, managing renewables in a high levels of penetration, more than 70-80% penetration, and that happened. Could have been avoided if we didn't have, to some extent, humans at the wheel. Were we actually monitoring all the parameters on that moment, interconnections with Spain, different imbalances throughout the country, renewables coming in, clouds passing on the southern part of Spain on that morning. So could AI have given us better predictive signals? I think we are not onto that yet. We'll need the comfort from humans as well, to same as flying a plane without a pilot there. Are we ready for that step? But I would just start over by saying that the sector is ready, but we are not doing the real value-added stuff, but it's coming.
That's really great, and you had so many good nuggets there. Two things that really stood out to me is it's not just AI for energy, but energy for AI, and just being aware that it's a dual dynamic, and always keeping aware they're happening at the same time. So how do we, at the same time as well, and this is quite timely, we launched, the forum launched a framework of which some of Kraken and Siemens contributed to, a net positive AI energy framework. How do we responsibly also do this? And that you find that the countries who are ahead in renewables, who had invested in energy years before, are actually ahead of the curve when it comes to adapting and integrating AI. So you really started to encompass what are the nitty-gritties then of how do we go about doing this. So thank you for that. Are there any responses for that from the rest of the panelists?
The fact is that what Pedro said, both sides, the managing all of the assets and optimizing them every 15 minutes, or every second, or every millisecond, and managing the customer interactions, we're doing today. It's being done today at multiple utilities right now. So when you ask people to raise their hand, there's a few dozen utilities in production, full production, running those systems right now, and there's clear value. So the answer is AI makes a difference. Humans cannot optimize hundreds of thousands of assets, EVs, solar panels, wind, and so on, in real time. And even in Spain, dispatch in real time the batteries to answer to what the grid needs. So that's happening today.
You speak of value. I just want to pick on that a little bit, because a lot of the companies that we speak with try to struggle to say, how do you measure the value? How do I go to my board members and say, this is why we should be using AI? Yep. How do you tangibly measure that? And how do you advise others could as well?
I think it's the wrong question. I don't care about why we should be using AI. I care about what problems we have.
Interesting.
Pedro just introduced 2 mega problems. Mm-hmm. If AI can solve it, great. If a person with a calculus machine can do it, great. I don't care. AI happens to be way better at solving the problem. So take flexibility specifically. Flexibility is the name for when we manage assets and flexibly take them up and down, charging, electricity consumption up and down. You can, and we see that today we manage about 500,000 assets in real time, mainly EVs, smart homes, thermostats, grid scale batteries. It's over 10 gigawatt of power. And there's a direct saving to the asset owners, either residential, so all of us as humans, or people that own big batteries. They save money, literally save money. Money is made on trading. You can monetize the asset. And the grid is more stable because we can balance the grid better. And the environment is better because it can time usage of clean power, which happens to be cheap, versus expensive power, which happens to be polluting. That's a direct win-win-win. Yeah. End user, utility, and the grid/climate, everyone benefit financially and kind of economically.
Amazing. Yes, please, Thomas.
I think another great use case is, on an obvious return on investment, is power quality, which we have been trying to manage automatically since decades. And we never really achieved that beyond pilots and I would say deep integrations, specific projects, but not in a platform, not in a scaling way. And I do see that this is finally happening. Now, why does it matter, right? For all of you guys, power quality issues, if not predicted well enough, and we're talking about things like harmonic distortions or the fact that renewables introduce more and more fluctuations in the network. So the networks become intrinsically more unstable. So you have to predict any kind of issues, quality issues in the network. And so data in general, and AI specifically, is starting to really make an impact there. But more in a platform way. So now, with Siemens, but also the community, many other suppliers are starting to do that, where you use the same platform, the same software for industrial customers, for distribution operators, and for transmission operators to help them predict any kind of power quality issues, which could lead to outages, damage of equipment, and if you get it right, you can, this prevents investments of billions of hardware in the network. So I'm seeing real impact there, using data and algorithms, AI, in that specific field. So that's a very specific use case.
Thank you for that. I'm going to stay with you for a little bit. Thomas, why do you think AI often looks promising in controlled environments, but proves harder to deploy reliably across real-world energy infrastructure?
Yeah, I already gave the power quality example, right? Where, until recently and still today, you need to integrate very deeply into legacy environments. We were talking about this right before the panel started, right? So, existing enterprise systems, you've got to deal with them. You've got to integrate. You've got to get the data out fundamentally. So the availability of data in the right quality, and we're going to talk about that, right, is the number one problem in the industry. The low voltage, medium voltage network, which is the network which is relevant for all of you asking to switch on the next EV charger, right, where the utility has a really hard time to understand if there is still enough capacity or not, and then it takes months to approve that interconnection request. Another use case, by the way, right? If you take that, then we're seeing more and more investment in the low and medium voltage network to actually have knowledge there, so get the data out. And as we discussed exactly 1 year ago in a panel here, a typical distribution operator has maybe 30-40% of knowledge of the network reality in the low voltage network today. And since last year, this has not changed a lot. So, so you just don't have the data. And that is the number one issue that prevents us from scaling these use cases.
Interesting. Cyril, yes, I was just going to ask you.
I don't want to be the bad guy on stage, but we need to acknowledge, because yes, there's hope. There's a lot of hope and nice POC, but the situation that we face is extremely fragmented and siloed in terms of data. SCADA, sensors, legacy, IT, OT systems that still need to be maintained as we speak. So even before, planning the next step. So, and this is extremely complex and a huge business and challenges for all of us. So the data remains extremely poor and fragmented. And that in some places, operators, they still rely on manual processes. So that's the reality. The second element is that there's fantastic, untapped value creation. So we are not properly managing, the storage. You're not balancing the supply and demand. So this is where the potential is. And the third thing is really dynamic, because as we speak, the complexity, as you said, Thomas, the complexity of systems is rising, because yes, more solar, more wind, more nuclear. So it is introducing different and new load profiles that makes it extremely difficult. So and I would say the complexity of modern portfolio linked to renewables will really makes imperative and mandatory the necessity to govern data differently, to clean data. This is a bad word, I'm sorry, and simplify processes. So we can talk about I will come back on hope, but first let's acknowledge that the starting point is complex and requires a major investment as we speak.
No, fair enough. And do you, and this is open to everyone, do you see any innovations that are coming up that are starting to address some of those challenges, and maybe not now, but maybe in the next 6 months, in the next year?
So actually, AI, in a weird way, the new wave of AI in the last year or two is much better at handling bad data than before. And I'll give the most basic example. When I used Gmail early on, I'm sure all of you, when you had your mailbox, I used to move every email to a folder. Do you remember the days? We spent 10 minutes every day to move the emails to folders. and now you just search for the email and it shows up. You don't need to put it in a folder. Data used to be cleaned and tagged all the time. That was 80% of the effort in analytics or AI, was to make the data, look good for the AI. AI is getting better, not perfect, but better at handling disparate sources and less organized data. Now, it's not perfect at it, but in a way, the trajectory is that the data issues are becoming slightly less painful. And what I find the biggest challenge is actually the humans, because they change slower than the machines. So in every AI panel on the planet, there's always two things come up. Data sucks, and the human's culture takes too long to change. And it's true. It's always the two biggest things to change. But I think also in the workforce, every employee we hire today is more AI native than all of us. So even that is slowly changing if you give it enough time. Trying to be positive.
I have another fun example for all of us, I think. And it's bad news, really bad news, and then good news, okay, for all of us. So we're experiencing more and more extreme weather events on both sides, right? So it's heat and cold, both, in many jurisdictions. Now, what that does, as you guys are the experts on this, right, obviously, what that does to your network map is that after a major weather event, it's wrong. So your digital twin or your representation of the network suddenly has changed, and conventional systems need days and weeks to actually update how my network just changed. And so there is a bunch of startups that are dealing with this reality and now building digital twins or network maps, knowing that there is major changes in the map all the time. So it's like I'm extending your thought, right? Which is you just deal with the fact that the data is really bad. So we need to unleash talent and data scientists into the energy grid, I think. And every new employee being native sounds great to me. AI native. I mean, that's the way we should go, because then there will be very creative solutions to get the data out of the system. So that was the good news.
Please.
No, but to build on that, first step when we start to develop AI agent to monitor capex, big infrastructure. This is the future, and this is where, frankly, the big challenges are as well. So we have this ability now to, in real time, to monitor what's going on your capex project development, and it's important because this is precisely the cornerstone of the development of sustainability. If we are not able to handle those infrastructure, the investments related to that will go nowhere. And this is, for us, a clear. This is an entry in the value chain where we'll have a lot of impact.
Oh, interesting.
Before, so when your program are installed, but before the first investment decision, the power of AI sits in the simulation. It can be perceived as something, okay, it's marginal, but frankly, it's massive. And after the FID, then we can play again with AI to make arbitrages and having time that far. So I'm a kind of dinosaur of this industry. I remember, you make a mistake. We made mistakes. We are not able to correct them. In big infrastructure, in nuclear, So this will be possible. In fact, it's already possible. So this is really for us, in a kind of very uncertain world, we are navigating those strange times, this ability to really anticipate and correct and adapt real time.
Which is very important. Staying on that practical aspect of data, when it comes to quality, when it comes to IP, privacy is also an important element in building trust. I want to go back to you, Pedro. As grids become more complex with large AI-driven loads like data centers, what has to change before operators can truly trust AI in real time for high-stakes decisions?
I was going precisely to go and reinforce the word trust, I think. And we're pointing out the speed of which we're seeing off-the-shelf ChatGPT models. Their improvement is massive. And so that is already there. And of course, people are more native. They know how to prompt better. So all of that, all of those fundamentals are kicking in. And two examples. We trade energy globally, and in Europe in particular, very deep liquid markets. We've been having for a while now digital twins on the side being managed by AIs, but disconnected to the grid, simply trying to mimic our own trading humanly driven strategies. And we, for months, have been beating them on the human side, but increasingly they are getting better. And sometimes you don't understand what they are suggesting, but then if you really think about it, you start to see an angle, which you didn't think before. So that is coming, and it didn't happen before. A second version of this is on the grid side. When we today manage grids, we don't want another blackout. And so today, the very thin line that we're walking is we're approaching levels of renewables penetration and complexity, but at the same time, if there's another blackout in Iberia, everybody's going to be fired. And governments are going to fall, utilities are going to suffer significantly. But at the same time, we need that innovation. We need that AI management. And so how to walk this line and how to build that trust today is, for me, a huge challenge. Yeah. That we need to have these digital twin models, bringing the ideas, confronting them, and trying to implement, either sandboxing small first and then improving. But if we don't cross precisely that path of trust, and we'll need quality data, we'll have all of those problems for sure. But we're reaching the limits of the system, and we need to break through at this stage. Unfortunately, this blackout had, on the glass half full version of it, put everybody around how to solve this, but the glass half empty is nobody wants to risk. That's why we're having CCTs operating 24/7 now in Portugal and Spain, spiking consumer costs because nobody wants the system to go down. And so how to cross this and navigate this trust issue at this stage, I think time will solve it. The question is how much and how long do we have?
Yeah, I think two things really stand out from what you said. With innovation comes risk, yes. And it's by default. But starting small and then iterating and getting bigger as you fix the kinks, I think is a safer way to build trust and with the solutions. Yes, please.
Just to add two thoughts, we came up with a concept we thought about as utility-grade AI. Because we realized there's a lot of companies doing amazing things with AI, Netflix, Amazon, and the like. But worst case, you see the wrong movie, right? You get the wrong book. It's okay. Then you have industrial shops, imagine NASA type companies, but they have one event every time. Utilities sit in this unique intersection. It's mission critical, and you have millions of substations and poles and consumers. It's a very unique combination. You need the agility of the Netflix and kind of the safety of those, NASA type. But there's one space, one dimension that it's happening today. We're driving EVs. I own an EV, self-driving. And the data shows that the EVs on self-driving drive much safer than humans. And there's millions of people there that literally push a button, read a book or be on the phone and let the car drive and risk their lives. So the thing about trust, there's one domain today where people every day choose to trust the machine to drive for them in a really life, critical type of scenario. And all the stats, all of them show it's saving lives. Now, I'm not saying we should do it tomorrow morning on the grid, because we have one grid versus, many, many cars. But it does show where we're heading, and it's quite interesting to think about it.
Yeah, absolutely.
I just want to stick with Kraken for a bit with how you're iterating or testing. You're using AI in pricing and customer operations, flexibility at scale. What technology choices have most enabled AI to scale across markets from your experience so far?
Yeah, so first, there's a fundamental decision we made before my time, smarter people, to be extremely agile. We update the software every 2.5 minutes. Not 2.5 years, months, minutes. And that actually makes it safer, and you can innovate faster. Because every change is tiny. And you can undo it, versus major changes that take years, and to undo them is really complex. That allows us to adopt new AI models and experiment at speed that you cannot do otherwise. Just imagine traditional way, you get a version, you test it for 6 months, you put it in, it doesn't work, you go back, you cannot be agile. So agility is kind of at the foundation, because AI is changing just faster than all of us. That was number one. And number two, not to be married to a single AI technology. I said before, I don't care about AI. I care about new technologies that can solve problems. There's new labs. They change every day. Someone else is better. Machine learning is still getting better, even though it's not cool Gen AI, still getting better. So not to be married or bet on one, just have this ability and agility to put new technologies in and change all the time. That's the foundation of what we do.
Amazing. Thomas, you wanted to come in.
I think, just to sort of structure this a little bit, you have a plethora of use cases here, right? And on the one hand, your network needs to be absolutely resilient, redundant, and needs to self-reconfigure if you have a power quality issue. It's like milliseconds, right? And then you go all the way up to planning software, right? Where you roll out the next substation in the next 5 years, or to pricing, right? So it's a whole world of use cases here. And and AI can play in different, in all areas, really, if we have the data and apply it. And I just want to give one more example here, more on the resilience and redundancy side. We're framing this idea of industrial-grade AI, very similar to you guys, right? Where, protection devices in the network, which today are, semi-automatic, really, if they identify a power quality issue, but not 100% rerouting or autonomous like an autonomous car. But that's where it's going. That's where the research is going. To identify zones in the network that are resilient in itself, and they should be sub-districts of cities, right? Or industrial campuses, but not a whole country, which goes to blackout. And that resilience per zone, of a like almost a democratized or modular network. That's the vision of industrial AI in the energy grids, right? And we're doing a lot of research around that. It's difficult, so that was a good news. Here comes again bad news. We're also switching off all these rotating masses, gas turbines and nuclear plants and all that stuff, and replacing it by solar and wind to a large extent, or batteries, or So you don't have this, this stabilizing top-down frequency, stabilizing force anymore, which comes through rotating masses. Now it's all power electronics on the edge. I don't know if that's good news or bad news, but you guys probably get the idea. So we need massive research and a concerted effort with all industry players to get a network going and overcome fragmentation, by the way, particularly in Europe, right? To have the resilient network with lots of renewables, which just managed by power electronics. So this is a call for action for massive research. And again, AI plays a major, major role there to understand how the power electronics behaves on the edge, right? So, a lot of capabilities, which, by the way, Europe can itself differentiate. I know I'm opening a totally different subject now. And overcome fragmentation, because we have these combined networks, which are all modular, but they're all dependent, right?
Yeah. So if I may, from a management standpoint, I don't know how Pedro will react to that, but we already see low-hanging fruits in AI, in utilities company, in HR, in CRM, sometimes massive, and so the ROI are there. It's not easy to handle in terms of organization because social issues, organizational issues, but we see that the impact is there. It's not, this time it's not a POC. It's happening for real. Then you have Siemens on the side, bringing a lot of innovations, a fantastic war machine of research and development. So the key question now is the focus. Well, we think that cleaning data and governance is a key one, but then we all think, and from I would say from Chevron, it's a question of infrastructure, from Total Energy, CapEx. So it's important to be at this point more specific and say, okay, what is the real focus we need to accelerate? I think we understand the broad picture on the AI is a fantasy accelerator, but now responsibility for managers in this industry is okay. How do I pick the right focus? Okay, I had my gallery, I had my factory, and now what is the next step? It's a question for you, Pedro.
Can I just add as well? Sorry, and very much on this line of focus, partnership, and cooperation. So Kraken and Siemens, these guys are the leading innovators. Then we try to be fast adopters, and you're already mentioning a couple of utilities are doing it. But we ultimately, energy in particular and electricity in particular, this is a highly regulated sector. and you need always government on the back end. And so you'll have 1,000 PhDs, we'll have 10 PhDs, government has 0 PhDs. And the idea that public and private must meet here somewhere on this dynamic, because it's not enough that you bring the solution, it's not enough that we see it and we want to implement it, but in the back end, you still need governments and government agencies to understand it, to be comfortable, because they'll write policy around it, they'll write legislation around it. And I still miss that end game as well of being fully integrated, and today van der Leyen said, we need an independent Europe, we have an amazing set of companies in Europe, but we still depend on this dual idea of Brussels and member states and how to implement all of these things. And so AI can definitely help on unlocking government resources, which they don't have. And we have eventually plenty on the private side. And so just adding this co-opetition and collaboration, we need to bring government along, we need to bring regulation and legislation along.
I think that's a great addition. It reminds me of something the Microsoft CEO said earlier. Innovation is only as great as the context that it's in. And I raised the question to the panel, how do we scale innovation across different contexts, I guess, across different regulatory markets, across different utility contexts? What do we think in the next 6 months is practical?
So just 2 data points maybe I think will help. We chose to focus only on utilities, only on energy, because we think there's a lot to do there. But you mentioned the regulators. Right now, Kraken alone has migrated 70 million homes, meters, with E.ON, EDF, ENGIE, Octopus, Planitude, Tokyo Gas, Origin, National Grid, can go on forever. All of them in the last 3 years. So we talk about the pace and so on. It is happening. Now, in all cases, we had to educate the regulator. They didn't have to change, in many cases, regulations, but they had to understand enough not to object. In the US, it's worse. Europe is ahead, by the way, materially. In the US, the regulators decide for the utilities. In Europe, there's a much better kind of environment. So you have to educate them, and you're correct. They don't have the PhDs, but they know what they care about. Affordability,
Prices.
reliability, right? Clean, depends on the region. So they know what they care about. If you can show them that you have done it elsewhere, they will want to do it in their country. If it's the first time, no one wants to be a guinea pig. No one wants to be a guinea pig. So to your question on focus, it's choosing a slice, hard focus, get proof points and success, and that is the only way for other utilities to adopt it, because it's a risk-averse type environment, and no regulator will let you do something for the first time across the entire country.
I want to move on to return on investment. How should different players be thinking about this? How are you thinking about this? And what should be the key area that should be a focus over the next year or maybe even 3 months, given how rapid the ecosystem is evolving? How are you thinking about return on investment?
I'll be a bit provocative. In fact, there are two key elements: sovereignty and ROI. So we need, we regulators, governments, companies need to get the balance right between, ROI and sovereignty. Sovereignty is a new power play. It's energy resilience together with AI are the new, will drive the world forward. So I like, the angle of ROI. Of course, we are all entrepreneurs, we have business, but it's important to put it, in front of the sovereignty and what is at stake. Basically, and even more in an industry that has invested over years. So I don't want to finger point my French friends, but for years EDF has invested massively in the name of sovereignty. And so, those moments are back. There are, of course, more financial constraints, but when we speak about ROI, let's have in mind that sovereignty is not far.
Interesting. And we find that coming up in our work as well at the forum, and sovereignty not being something you think of in silos. There's key components of that, of course, includes energy as a very important element, partnerships, as that came up on the panel as well, and capital, which also came up on the panel as well. What about the rest of our panelists here? How are you thinking about return on investment?
I can comment as well, but whenever you say the next 3 months or 6 months, so we invest in 30-year timeframes, and so we need extreme predictability on that standpoint. So geopolitics does not help, but trying to help to think to consider the current context. somebody needs to pay for all of this. And so somebody needs to pay a final electrical bill, for example, or a final data center prompt. And so the theme of affordability is eventually should be our benchmark. And then when we backtrack, we understand today that we have a much more complex system that without intelligence, without managing complexity, even without AI, it's bound to be more expensive. And so if it's more expensive, it's not affordable, there's no chance that we make our ROI. And so we need to ensure that affordability is a goal. And if we play it right, we are seeing that there's plenty value pools there on the renewables generation, on flexibility, on grid management that delivers a final product that is acceptable and there's willingness to pay, but at the same time, it delivers value and an ROI for an entire value chain. And we see today, for example, we have, and I'm not committing any confidential information, but we have, for example, Amazon as a customer for off-taking PPAs. We have current contracts with them in the US, Brazil, Portugal, Spain, Poland, Japan. The most expensive contracts that we have are in the US. And the US, it's the one that has cheapest natural gas. And so Europe today is being able, through its renewable penetration, so the nuclear in France, to a certain extent, the Nordics hydro, and the Spanish solar, we've been able to provide a massively GDP-linked electrical system, which is highly competitive. Now, it's getting more complex, and we need to be able to manage that so that it doesn't spiral out of control. That's why that innovation is critical, talent is critical, and so on. So we need to keep the eye on the ball on the affordability, but there's clearly a value pool here behind to enable Kraken, Siemens, and the utilities, Capgemini, to make its own fair share of value, for sure.
Thank you for that.
So ROI and regulatory framework are two sides of the same question, really. If you stipulate, like Ofgem has done in the UK, that utilities simply need to provide the data, in the low and medium voltage network, then suddenly your ROI changes. Because then, if you combine that, by the way, second example, with dynamic pricing, which we don't have time to get into the details here, right? To get the right incentives for the flexibility markets to develop even faster, then large industrial customers would actually, invest in flexibilities much more than they do today. So listen to the signals of, it's afternoon with lots of wind and solar, the price is very low. Right, so I'm going to change my industrial processes to the extent possible, right, to consume now and then consume less at 6 p.m. where there is less wind and no solar anymore. But these signals, they don't trickle through because of the lack of dynamic pricing without us having the time to really get into that. So dynamic pricing and data availability, like Ofgem, stipulated it, that would be, from a regulatory point of view, already a hell of a lot to actually get better ROIs, in the system.
Maybe two final thoughts to be pragmatic. I would divide experimentation with delivery of projects. Every project we're doing, and I think every project anyone is doing, should have a positive ROI and meet sovereignty and meet local regulatory requirements. I don't think it's mutually exclusive. You need all three, and if not, improve the technology. It shouldn't be either or. Totally separate. I believe every CEO in 2026, I was about to say 2025, every CEO in 2026 needs to put some money aside to experiment with AI and let the entire population try new things. And if it did not work, try it again in 3 months, because the entire AI technology stack changed. Even in the last 3 months again with Claude and so on. So put aside experimentation, which is culturally important, technology important, data-wise, you uncover your data sets, put money there because you build a muscle that is the muscle for the future. But when you do an actual production project, it should have positive ROI, and there's no reason it wouldn't.
One question, well, we'll get to similar key points that you think CEO leaders should be focusing on right now, and if not, you should be. Also, in the theme of Davos, partnerships, are there any interesting strategic partnerships that you think are key to enabling any of these strategic moves that people should be part of, or if they're not already, become a part of?
I don't want to take the oxygen in the room. One sentence, I see more and more utilities that thought they can build in-house all of this technology stack, and they realize it's moving so fast, you have to partner. One partner, multiple partners, the big tech companies, special energy companies, it's a choice. You cannot do it alone.
Cyril, for Capgemini, I know you have an overview of across different industries, industry partners. How is it looking? Is it one model works well, or?
I think we try to get the balance right between sovereignty for our clients and manage the ecosystem. So this is really where the challenge is, because you saw over the last months that the tensions between those two dimensions are real. But I think there's no we can't pretend, innovate and take it over. So it's a matter of manage a strong innovation ecosystem inside and outside with partners like Siemens, as I said, and keep in mind that the client expectations are stronger and stronger on the resilience and on the sovereignty of the providers.
Thank you for that.
I mean, partnering is a loaded question, right? There is, there is the need for massive partnering in this whole ecosystem. So I gave you the power electronics network of the future example, right? Where all providers, all tech companies like, Siemens and our peers, the utilities, the regulators, we got to set the standards to make this network work when we have switched all rotating masses, right? So there's massive partnering. And then, embrace the AI startups out there that can build, better grid maps with less quality data even, right? Just embrace it, work with them. So, partnering is happening on all fronts, really, because once in any industry we're talking about, that embraces data is naturally getting into a massive partnering play because data is available for all the industry players.
Yeah. Just add that one of the key and most complex and interesting dynamics that we're having today is we're being asked to quote baseload energy for a specific data center, 24/7, 10 years, 15 years. And we're providing a dumb price, assuming that they're going to ask for those same electrons every day of the year with a fixed profile. Then we say, okay, but if you were to give us, say, hourly profile or a 15-minute profile or a minute profile, I can actually source you much better. But then we start to block because they don't want to share, and they don't have that trust once again, and they don't know what we're going to do with that, and can we compete tomorrow in a neighboring country with that data? And so it's a very interesting problem today to source because we are providing, or the industry is still working on dumb solutions because of that trust, but maybe that trust never gets, we're never able to cross that path. But if we are able to unlock this end-to-end massive consumption into flowing to grids, flowing into resources, there's a lot of value here to be done. Then does it mean that we need to co-invest and they need to co-invest on both ends of the spectrum so that we have incentives aligned? So we're moving along these, and so you can call it partnering, but it's a huge value pool to be able to get these ecosystems working with full, almost open book transparency and allocated returns for each party. It's an interesting problem today that we're having.
Interesting. Thank you. Yes, please.
No, just because we have to mention it, even if today you understood that we are on the sunny side of the topic, but the cyber topic is there, and AI and cyber, of course, go together. So here, it was difficult to share it publicly, but we start to develop a lot of solutions, allowing, the resilience. This is really, we are very basic and pragmatic on that. But this is something that popped out in the last 2 years, and where AI shows the stronger added value.
Thank you very much. So we heard what's working, what needs to work, and what promises are ahead. Thank you so much to our panel. Thank you so much to our participants.
Thank you.
Thank you.
Have a great rest of the Davos.